All right, so this is a review for Monday, May 2nd. All right, this is a a soil texture triangle. Talked about this briefly before. And what you're going to do is they're going to say it's 60% silt, 20% sand, and 20% clay. And so for clay, you find the 20% and you go straight across. For silt, they angle downward. So you're going to find 60 and go down. And for clay, they angle upwards. So you're going to go to 20 and go up. Where those three things meet, that is your the type of soil. In this case, it would be a silty loam. Now, if they don't all meet, then you probably did something wrong. So try again. Eutrophication is the addition of extra nutrients. Eu means beyond, troph means nutrient. So if fertilizer from someone's lawn or farm washes down into a river, lake, stream, ocean, what's going to happen is those extra nutrients are going to cause the algae to reproduce like crazy. We call that an algal bloom. Now eventually, when the nutrients run out, those algae are going to die because they don't have enough nutrients anymore. And when they die, they get decomposed at the bottom, and that uses up oxygen, which means the water, the lake, becomes hypoxic or a low oxygen environment. Another name for this is a dead zone, when there's not enough oxygen for the fish that live in the water. So fertilizer can be a pollutant when it's in the wrong place. And we call that eutrophication. It can lead to an algal bloom and then eventually to low oxygen. Contour farming is where you build rows along a sloped surface. And those rows help to reduce the water movement, and so you have less erosion and you have more infiltration. Drought is where you have like very little or no rain for an extended period of time. Like if you go a couple of days without rain, that's not a drought. If you go weeks or months, then you start talking about droughts. All right, so droughts would decrease runoff, but it's also going to decrease infiltration. Contour farming decreases runoff and increases infiltration, the movement of water into the soil. Okay? If you had a lot of rain, you're going to have a lot of runoff, and you're also going to have more infiltration. All right? Wetlands, they can be marshes, they can be swamps, they can be bogs. There are differences. For example, swamps have trees, marshes do not have trees. But they're all wetlands, and all wetlands filter water and soak up flood water. So when a developer wants to drain a swamp or a marsh and build a strip mall, they're going to increase the chances of flooding because there's no longer that swamp to soak up that flood water. And they're also homes to lots of different kinds of plants and animals. That's the biodiversity. All right, if we have a cold front, cold fronts are drier air, they're less humid, and they tend to be denser because the air molecules are much closer together. Okay, warm fronts, on the other hand, tend to be more humid or wetter. They have more water vapor, and they're less dense. And the reason is the cold water, the molecules are so close together, there's no room for extra water vapor to be there, so they're drier. And they're more dense, so they tend to be closer to the ground. Warm fronts might very well start near the ground, but they're more humid because the air molecules are so far apart that there's more room for water vapor to join them, right? And they're less dense, again, because the air molecules are so far apart. And so if these two are coming towards each other, the warm front is going to go up and over the cold front. And as it does, it's going to start to condense and form a rain cloud, and that rain cloud is going to increase the rain. All right, so warm front going over cold front, you tend to get precipitation. Solar flares, volcanic eruptions, El Nino, greenhouse gases, these are all things that increase climate change or affect climate change. Now, solar flares don't happen very often, but there is some historical data to suggest there's a connection. Volcanic eruptions, now we're talking about big volcanic eruptions. They can certainly have a local impact near where they erupt. Really big ones can actually blanket a good portion of the atmosphere with smoke and dust and ash and cause some climate change, short-term climate change. El Nino is an ocean current that flows from South America to Africa. And every few years it reverses and we have what we call La Nina, going the other way. But here's the thing, this ocean current way down between South America and Africa, it affects our weather in North America, okay? So ocean currents, especially El Nino, can affect climate. And of course, greenhouse gases affect climate. And especially all the extra greenhouse gases us humans put into the atmosphere. All right, let's say we have two farmers. Now, farmer A only plants blue corn, okay? And just blue corn, that's it. On the other hand, farmer B plants 3 different kinds of sweet corn, all right? They're all sweet corn, but one is the blue variety, one's the green variety, and one's the red variety, okay? Now, a new virus comes along and it only kills blue corn, all right? So what's going to happen is farmer A is going to lose all or most of his corn, okay? And he's going to have a very poor harvest time. On the other hand, farmer A, he can lose, or she can lose their blue corn and still have corn left to sell because farmer B had more biodiversity in his crop rotation, okay? So when biodiversity goes down, there's an increased vulnerability to pathogens for the species or the crop. When we have controlled growth, there's less erosion, soils are better. If we have uncontrolled population growth, okay, then what's going to happen is we have to house all those people. We have to build houses, we have to build roads, we have to build skyscrapers, we have to cut down forests. So when there's uncontrolled population growth, there's going to be greater erosion, and the soil is going to have less fertility. That should be an E. Okay? All right, and that's it. That is your review for Monday's classwork.